Hi, my name is Shahroz Ahmed, and in this video we are going to cover a topic of Calculus 2, and the topic is the integration techniques. In Calculus 1 I have covered the basics of the integration, but now I'm going to discuss the topic on the integration techniques, like if we have been given the integrals, so by using several techniques how we can integrate them. But just as a recap, integration is just to measure the area under the graph. So if I say that I have to integrate something, so integration is basically finding the area under the graph. Integration is finding the area under the graph. So that is why we have to integrate a function. So let's suppose we have a graph just like this, and if we have to find out the area under this graph, we have to integrate the function of this graph, that is, let's suppose f of x. Alright, so now we're going to discuss some of the techniques by which we can integrate several functions. The first technique that we have to discuss is the integration with u substitution. So let me just erase it. So integration with u substitution. So let's suppose we have this function for which we have to integrate it. It's cos x square times 2x dx. Now it's not only cos x square whose integration is possible. There's a function cos x square that is being multiplied with another function of x, that is 2x. Now over here we have to integrate it by doing the u substitution. Now observe carefully. You see over here x square, and the derivative of x square, that is 2x, it's present outside. So you have to carefully observe such a function whose derivative is available somewhere in the numerator. So what you do is you will simply say that let u is equal to x square. So here you can write let u equals to x square, then du by dx will become equal to 2x, and u, because you are substituting u in place of x square, so you have to write dx in terms of du. So from here we'll make dx as our subject, so it's like dx is equal to du over 2x. Now in place of x square we will substitute u, in place of dx we will substitute du over 2x. So it's integration cos of u times 2x times du over 2x. Now this 2x and this 2x will get cancelled, and our integration will be simplified. It's cos u of du. So the integration of cos u is sin u, so it'll be like sin u plus constant. Now we'll put back the value of u, that is x square. So our answer will become equal to sin x square plus constant. So this is how we can do the integration with u substitution. You just have to observe carefully the function whose derivative is present. Alright, so this integration is basically for the indefinite integrals. Now let's see the integration for the definite integrals as well. Okay, so now we have a question. It's integration from 1 to 5, and the function is 2x plus 1 times x square plus x whole cube dx. Now this is the definite integral, so at the end of the answer we will not write the constant. Instead of that we have to put the upper limit and the lower limit. So in this one, just observe carefully, this function x square plus x has the derivative present over here. So the derivative of x square plus x is 2x plus 1, it's present over here. So what we do is we simply have to suppose that let u is equal to this function. So I'll write it over here. Let u is equal to x square plus x, so that du over dx will become 2x plus 1, and dx will become equal to du over 2x plus 1. Now I'll just do the simple substitution. I'm not like touching these limits. I'll do them at the end of the question. So it's from 1 to 5, 2x plus 1 times x square plus x. So in place of x square plus x I will insert u. It's u cube. Now in place of dx I will put du over 2x plus 1. 2x plus 1, 2x plus 1 will get cancelled, and our integration has been simplified. It's u cube or du from 1 to 5. Now I'll integrate it, and the integration will be u to the power of 4 over 4, and the limits will be from 1 to 5. Now we cannot insert these limits into u because the limit 1 and 5 are not the limits of u, so we have to put the value of u back and then we'll insert the limits. So the value of u is x square plus x, so it'll be like x square plus x to the power of 4 whole divided by 4. Now I can insert the limits from 1 to 5. So when I'll insert 5 over here, it will become 5 square plus 5 to the power of 4 whole divided by 4. Minus sign, now I'll put 1 into x, so it'll become 1 square plus 1 to the power of 4 whole divided by 4. I'll just put that into the calculator and get the answer. So the answer will become 202496. That's the answer. So this is how we will do the questions by the u substitution for the definite and indefinite integrals. Now the next thing that we have to discuss is the integration by using the long division. So let me just erase it and then I'll do that. Alright, so now we have to discuss the integration using the long division. So let's suppose we have an expression that we want to integrate. So it's the integration of x minus 5 divided by negative 2x plus 2. So in this one you can see the function in the numerator and the denominator, and they are not solvable, and we cannot do the u substitution for this one. So for that purpose we will just divide it, we will simplify the function, and then we can use the normal integration techniques to integrate it. So I'll do the process of long division. In the long division I'll keep x minus 5 inside this division sign and negative 2x plus 2 outside this one. Alright, so we have to see the number by which we will multiply negative 2x, so it will become 1x, so that will be equal to negative 1 over 2. So it's a negative half. I'll multiply it with this one, so I will get x minus 1, so it will become x minus x will become 0, and minus 5 plus 1, it will become minus 4. So this expression will simplify to minus half plus minus 4 over minus 2x plus 2 dx. So now we can integrate it. So the integration of minus 1 over 2 dx plus integration of minus 4 over minus 2x plus 2 dx. For this purpose I'll use a u substitution. So I'll say that let u is equal to minus 2x plus 2, so that du over dx will become equal to minus 2, and dx will become equal to du over minus 2. So this one will become minus 1 over 2x plus, over here we'll have integration minus 4 over u, and for this one I'll put du over minus 2. So minus 2 and minus 4 will get cancelled, and in the numerator we will have only 2. Alright, so it will become minus 1 over 2x plus integration of I'll take 2 outside, integration of 1 over u du, which will become equal to minus 1 over 2x plus 2 ln u plus constant. Now I'll put the value of u back, and my final answer will become equal to minus 1 over 2x plus 2 ln minus 2x plus 2 plus constant. So this will be my final answer for this integration by using the long division. Alright, so this is how you can do the integration by the long division. Now the next thing that we have to discuss is the integration by the completing square method. Alright, so now we have to do this integration by the method of completing square. So as you can see that we have this expression, we have to integrate it by using the completing square. So first of all I will take 5 common from the denominator. So it will become 1 over 5 integration of 1 over x square minus 6x plus 13 dx. Now I'll do the completing square. I'll make the denominator as the perfect square. So it can be written as 1 over 5 integration of 1 over, I'll write x, this minus sign as it is, then half of 6. Half of 6 is 3. I'll close the bracket and square it. Then I'll put a minus sign. Half of this number, like half of the coefficient of x, so that will be 3. I'll square it plus the remaining number, that is 13. So I'll write it over here, dx. It will become equal to 1 over 5 integration of 1 over x minus 3 whole square plus 4. Now over here I have to divide the numerator and denominator by 4 to make this as 1, because I'm looking at this will become a formula of tan inverse x, integration of like the derivative of tan inverse x, that will be x square plus 1 dx. That will give us tan inverse x. So I have to convert this whole thing into this form. So for that purpose I'm gonna divide the numerator and denominator by 4. So when I'll divide the numerator by 4, it will be over here, and when I'll divide the denominator by 4, it will be like 4 by 4 divided by x minus 3 over x minus 3 whole square over 4. So I can write this 4 as 2 square. This 4 will get cancelled, and in the next step it will become 1 over this 4 will come outside, and this 5 will be multiplied with this 4, and it will become 1 over 20 integration of 1 over, now it will be x minus 3 over, now this 2 square will go inside the bracket and it will become x minus 3 over 2 whole square plus 4 over 4 is 1, it's dx. Now I can use the method of substitution. I'll substitute x minus 3 over 2 as u, and this whole formula will become the integration of this whole formula will become tan inverse of x, like the integration of this whole thing will become tan inverse of this function. Anyway, so I'll say that let u equals to x minus 3 over 2, so that du over dx will be equal to 1 over 2, and dx is equal to, dx will become equal to 2 du. So I will just substitute everything over here. So it's like 1 over 20 integration of 1 over u square plus 1. In place of dx I will put 2 du. This 2 and this 20 will get cancelled, and we will have 1 over 10 over here. So it will be like 1 over 10 integration of 1 over u square plus 1 du. So it will become 1 over 10 tan inverse u plus constant. So that will be our answer, but now we have to put the value of u back. So the final answer will become 1 over 10 tan inverse x minus 3 over 2 plus constant. So this is how you can do the integration by the method of completing square and substitution. Alright, so after this one, now we will try to integrate some of the trigonometric functions. Alright, so for the integration of trigonometric functions, let me just write down a function that is cos cube of x dx. We have to integrate this function. Now look carefully what I'm going to do with this function. So it's like integration of cos x times cos square x dx plus equal to, now you can see over here this is the function cos square x. So what I'll do is I'll say let u equals to cos square x, so that du over dx will become equal to 2. Well, we don't do the substitution for this one, so basically we will replace cos square x by 1 minus sine square x, because we know that there's a trigonometric identity that says cos square x plus sine square x is equal to 1. So the cos square x will become equal to 1 minus sine square x. So it will become integration of cos x times 1 minus sine square x dx. Now I'll just expand it, and it will become integration of cos x minus cos x sine square x dx. All right, so I can separate them, so it will become integration of cos x dx minus integration of cos x sine square x dx. Now I'll do the substitution. For this one, its integration is quite simple. It will become sine x. For this one, I have to do the substitution. So for this integral, I will say that for the first one, it will become just sine x plus integration of cos x sine square x dx. So for this one, I will say let u is equal to sine square x, so that du over dx will become equal to 2 sine x. So this u is equal to sine x, so it will become the du by dx will become cos x, so that our dx will be equal to du over cos x. Now I'll just substitute it over here, and I will get sine x plus integration of cos x times u square times, in place of dx I will put du over cos x. So this cos x will get cancelled, and I will have sine x plus integration of u square du, which will be equal to sine x plus u cube over 3 plus constant. I'll put the value of u back over here, so I'll get sine x plus sine x cube over 3 plus constant. So finally my answer will become equal to sine x plus sine cube of x over 3 plus constant. So this is how we can integrate this function. Now in the next part, we have to do another integration of a trigonometric function. So let me just erase it now. Alright, so now we have this function sine square x times cos cube dx, cos cube x dx. So we have to integrate this function. So first we'll break it down, and then we will use our integration techniques of substitution to integrate it. So first of all, I will write cos cube x in the form of cos square x, or cos square x times cos x dx. Now I can write cos square x as 1 minus sine square x. So I'll write it over here like this. It's sine square x times 1 minus sine square x times cos x dx. Now I'll just expand the brackets, so it will become integration of sine square x minus sine to the power of 4x times cos x dx. Now in place of sine x, I'll substitute u, because the derivative of sine x is present over here, that is cos x. So I'll substitute, I'll say let u is equal to sine x, so that du by dx will become equal to cos x, and dx will become equal to du over cos x. So in place of dx, I will substitute du over cos x. In place of sine x, I will substitute u. So it will become u square minus u to the power of 4 times cos x times du over cos x. So this cos x got cancelled, and my integration will be simplified to u square. This is du over here, u square minus u to the power of 4 with respect to du. So I'll just integrate them separately, and it will become u cube over 3 minus u4 over 4 plus constant. Now I'll put the value of u back. So the value of u is sine x, so my final answer will become equal to sine cube x over 3 minus sine to the power of 4 x over 4 plus constant. So this is how we do the integration for such trigonometric functions. So these were the integration techniques that I had to discuss with you for calculus 2. So this is it for this video. I hope you liked it, and thank you so much for watching.